Let's design a laser reflector in Onshape and machine it using Cam Studio. As of this recording, Cam Studio is included in the Onshape Professional and Enterprise plans, and EDU Enterprise coming soon. Let's get started with the design phase. To ensure the reflector fits the existing design, I'm going to create a new part studio in context to reference the fastener locations of the mounting brackets that are already present in my assembly. I can now see a ghosted out version of the assembly in my part studio, and using the managed assembly state as a reference, I know I can have this part have a footprint of 178 millimeters square. This is where my in-context references will come into play as well, as I can use the use command while sketching to project the mounting hole locations from the brackets onto my new part. This creates an in-context relationship between this sketch and my assembly. Now that I have my footprint and references created, I can extrude my part out 50 millimeters to start creating my reflector part. With Onshape, you can have multiple managed in-context references in a part studio, so I'm going to rename this if I decide to come back to it later and create more references, as well as hide the context objects that aren't necessarily important to my reflector design. With my new part, the in-context benefits come back into action. I can use the hole locations I projected in the first sketch to define where my tapped M10 fastener holes are going to be added to my model, ensuring that they'll line up with the mounting brackets once I insert this back into my assembly. As I continue to design this part, I want to make sure that it's as light as possible. To help with this, I'm going to add some pockets to the top face of the reflector. This area is just where the reflector connects to the brackets and isn't actually reflecting anything, so I'll remove bulk amounts of material to keep it as light as possible, but add ribs to maintain the structural integrity that I need. I can use Onshape selection tools to quickly choose all the edges of the same length so that I can add fillets to the walls of my newly created pockets. I'll use the same process of selection when I add fillets to the outer edge of my bracket as well. For some final details, I'm adding a chamfer to the top edge of the reflector and drilling out another hole in the center to make it even more lightweight. Notice here how even if I don't have a sketch point defined at the center of this face, I can use a mate connector to define the location of this drilled hole. Before I consider machining this part, I'm going to use the in-context menu to insert this part back into my assembly. Now that I have my part in my assembly, with Onshape's intuitive mate structure, I can quickly fasten the reflector to the mounting brackets with just two mates to define the entire relationship needed. Additionally, I can use Onshape's standard content library to add correctly sized fasteners to the mounting bracket to hold the reflector on. Now that we've verified the fit of this part, it's time to machine it using Cam Studio. This video shows a step-by-step process of machining your part from the beginning component selection to outputting G-code and storing it inside your Onshape document right alongside the rest of your CAD. First, I start by bringing in a version of my newly created part into Cam Studio. This is the first, but not the last time that you'll see Onshape's built-in data management be used with Cam Studio. Now it's time to set up my job. I select my newly created reflector as my driving body and define the stock based on the 2-inch by 8-inch stock that I've purchased. For today's case, I'm going to select a generic Haas 3-axis CNC machine, but there are many more tools, all with their own post-processors, included in Cam Studio. Try it out for yourself with Onshape's Discovery program to see the whole list of machines. Once I set up my coordinate system and have my stock defined, it's time to select my tools. As you'd expect, I'm going to start with milling operations. In this case, I have a 12mm end mill that I've selected from my personal tool library, which I've already started curating. If I haven't created a tool yet, I can easily customize a new one. Let's dive deep into toolpath creation. To start, I'm going to create a roughing operation to remove material in bulk from the stock. If I have any questions about the roughing sub-pattern options or any other tools within Cam Studio, I have a tooltip here to help me out. This rough is only going to be for the inner pockets of my design, which I'll define under edge containment, but I'll make sure to have remachining turned on for future toolpaths to reference. The last step for creating my first toolpath is to go under the Link tab and modify the ramps parameter so I can improve the efficiency of my toolpath. Whenever you finish a toolpath in Cam Studio, you calculate the operation and then generate the in-process stock that gets updated at each step along the way. This is super helpful to quickly review the results of the toolpath that I just created. Let's take a look at the result of our first toolpath. By checking this box, I can see the path of my cutting tool relative to the stock and the reference model. With this turned on and the backplotting option running, I can see the movement of the machine relative to the stock. This can be my first line of defense to see if any unintended or inefficient movement is happening at this step. If I want to take a deeper dive into a certain toolpath, I can choose the verification option. This actually lets me see both the path of the cutting tool and how material is being removed from the stock at this current step. If I ever need to, I have full playback controls for this option to visualize this removal at an ideal pace for myself. I'm happy with the results I'm seeing, so let's keep moving along. As a secondary step, I want to do a 2-axis rough on the outer edges of my stock to get closer to my desired edge radii, since I didn't include this in my initial roughing operation, and we have to remove a large amount of material from the stock. Inside the toolpath, I'll select the outer edge of the reference component as the driving edge, and then do the rough over the course of 3 slices, with remachining once again turned on based on the stock that I have now. With the general outline of my part created, let's start some finishing operations on our stock. I'm going to start with a flatlands operation to face off the bottom of the internal pockets. For precise cuts, I'm adding a radial offset to the toolpath, and I'll finish the walls further down in my toolpath. There is a small amount of material that needs to be removed from the top face of the stock as well, so I'll add another flatlands operation, this time adjusting the height parameter so I scope my cut properly. Once I'm all set with those, I'll use a 2-axis profile operation to finish the sidewalls of the pockets. From viewing the toolpath that I just created, I'm actually going to go back and change the step down parameter to be number of slices related, since I think I can be more efficient with this toolpath. Now that I've regenerated this operation, I can continue on with the rest of my toolpaths. From the larger triangular pockets that we just created, I can just duplicate my toolpath and change the reference edges to create my 2 rectangular pockets, since they're at a different depth than the other pockets that I need. My last 2-axis profile is used to machine the remaining material from the outer edge of the reflector. This wraps up my tooling with the end mill, and it's time to select a 45-degree chamfer mill to machine the upper edge of my part. In this chamfer toolpath, I'm actually going to remove the offset from it since it'll be a finishing operation. Let's take a look at the stock so far. Our CAD model matches the machine portion of the stock in front of us, and as you've seen me do already, I can go back at any time and update any of my toolpaths if I need to. Now that I'm happy with the milled result of my stock, it's time to finish off with some drilling. First, I'm going to start with my mounting holes. I'll use a slightly smaller diameter drill for this since I'm going to tap these later. Then, I'll select a new drill bit to machine the clearance hole in the middle of the part to remove some more mate. Then, I'll select a new drill bit and machine the clearance hole in the middle of the part to remove some more weight. And there we have it. We've finished the machining operations needed to create this part, and it's time to use Onshape's built-in machine simulation to validate my toolpath. With machine simulation, we're able to see the entire machining operation of my reflector part in context to the machine that I'll be milling on. This is all done with Onshape's cloud computing capabilities, so that it can even be done on a simple computer right inside your machine shop. Watch here as material is removed from the stock while referencing the physical machine setup with one of our preloaded models that's included in Cam Studio. At any point in time, you can rotate the model around to get a new view of your part as it's being machined and toggle many of the elements that you see on your screen. My simulation went off without a hitch, and I'm happy with the toolpath that I've created to machine this part. To close the loop on this entire process, I can post-process my G-code directly from the Onshape interface. Once I've reviewed the output and I'm happy with it, I can upload the NC file into Onshape and make sure that anybody who has access to this document is also able to review the NC data. I did tell you that PDM was going to come back into play, and I can use Onshape's built-in revision control to release my NC file to production and manage it right alongside my CAD data. This is all because of Onshape's built-in PDM environment that unites CAD, CAM, and any reference documents that you need for your design. In addition to this, if I ever want to adjust my machining setup, I can take advantage of Onshape's branching capability to try an alternate approach to tooling without having to do a save as copy and create a new file to manage. It's just all managed directly inside of my Onshape document and always connected. This completes my machining and design process for this part, and here's the final assembly result. Thanks for watching.